So we get 415.7. So up next, we're gonna go ahead and do just transfer back over to my notes. All right, so if you look at it, we got 415.7. So if you compare 415.7 times 10, you could kind of clearly see that 415.7 is bigger than 10. So since 415.7 is greater than 10, we say our data set is approximately normal. Right. And that's it for part A. Any question in regard to part A? All right, no question in regard to part A. All right, so for part B, we're gonna go ahead and find the critical value for a 90% confidence level. So right here, all you have to know is that we're doing a 90% confidence level. So what I'm gonna do, I'm gonna use a t-table in order to help me get the z value for this. Because pretty much what we wanna do, we wanna find what z alpha divided by 2 is equal to. So all we need to know is that we want a 90% confidence level. So I'm gonna go ahead and just switch over to the t-table. So here,
what does z represent again?
the critical value.
Critical value. Okay. Thanks.
All right, so right here, we're looking for a 90% confidence level. So if you look right here, 90 is over here. So you get the number right above it because that's the z row. So if you look at it, you get z is equal to 1.645. So you get 1.645, 1.645, 1.645. And that's it for B. Any question in regard to how you find 1.645 for the critical value?
So if we have the confidence level, we just check that table to find z.
Correct.
We don't need to find anything by hand. Okay, great.
Yeah, pretty much you're just using that table just purely to get the z value for that. Okay, so if you look at C is asking for the point of estimate. So the point of estimate is p hat, which in order to find p hat, you have to do x divided by n. X in this case is 1,123, all divided by our n, which is 1,783, which we found out to be 0.6298. So that's your point of estimate. So if I ask you for point of estimate, for this one, since we're doing it for proportional data set, you want to give me p hat. Like once we get to 8.2, well, sorry, 9.2, you're kind of going to notice point of estimate also referred to the sample mean. But for right now, since we're doing this for proportional data set, the point of estimate for proportional data set will be p hat. All right, any question for C? All right, let's do D. All right, so for D, it says find the margin of error. So if you remember the formula for margin of error, is V alpha divided by 2 multiplied by square root of p hat times 1 minus p hat, all divided by n. So if you look at B and C, we're going to use the information that we got for B and C in order to help us figure out what D is. So if you look at D, we want to find Z alpha divided by 2. We already found Z alpha divided by 2 is 1.645. So you get 1.645. You're going to multiply this by radical p hat. P hat in this case scenario is 0.6298 multiplied by 1 minus p hat, which is 0.6298, all divided by n, which n is 1,783. All right, so that's how you want to just substitute everything in. So now that I have everything substituted in, what I'm going to go ahead and do, transfer over to the TI-84, and I'm going to do those calculations on my TI-84. So turn it on. So first we're going to do 1.645. We're going to multiply this by a radical, and then you're going to put 0.6298 multiply by 1 minus 0.6, oops, that's not a 6, that's a 9, 6298, close parenthesis, and then you divide this by 1,783. So then you go enter. So we get our margin of error is 0.0188. So that's the margin of error we're getting. So if you look at it as a percent, approximately we're getting a 1.9% of margin of error. So that's the room that we have to be from the point of estimate, because we kind of know the point of estimate is probably not going to be the true population proportion, but the margin of error, you're telling us how far away we could be from the point of estimate and still be considered correct. So this is telling us we could be approximately 1.9% away from the point of estimate, and we will still be considered correct if we are. All right, but any question on how to find the the margin of error? All right, so up next we're gonna go ahead and do part E. Part E, if you look at it, it says construct a confidence interval. So construct a confidence interval mean where you get the point of estimate and where you get to add and subtract it by margin of error. So we're gonna say P hat plus or minus margin of error. So that's going to translate over to P hat, which is 0.6298 plus or minus my margin of error. My margin of error in this case is going to be 0.0188. Any question where I got 0.6298 plus or minus 0.0188? All right, so I'm gonna go back to the TI-83. I'm gonna do that calculation, and that's gonna be our confidence interval. So we're gonna get 0.6298 minus 0.0188. If you do that, well, you get 0.611. I'm gonna do this operation again. The only thing that's gonna change, instead of having a negative, I wanna make it into a positive. So you get 0.6486. All right, so that's our confidence interval. And just remember, for a confidence interval, the lower number should be on the left side. The higher number should be on the right side. So 0.611 should be first. 0.6486 should be second, because 0.611 is smaller than 0.6496. So you never want to put the bigger number first. You always want to put the smaller number first, because that's how you want the interval to be. So any question in regard to how we found the confidence interval? All right, so let's do F. So F is asking, is it plausible that the true proportion for all registered voters who are in favor of the death penalty for those convicted of murder is 75%? So if you look at it, it's saying, can the true proportion? So they're telling me, hey, is it possible or is it plausible that P could equal to 0.75? So
No.
it is asking me, is it plausible? And in this case, we're going to say, yes, it is plausible. Because just remember, for this one, anything could occur. And then if you look at part F, F is not referring to what we got from our confidence interval. So we don't want to use our confidence interval to make the decision. For part F, we just want to say, hey, since since 75% is an option, it is plausible that 75% of registered voters who are in favor of the death penalty for convicted murder. If you look at part G is saying based off of your confidence interval. So in G, you want to use your confidence interval to make this decision. So for part F, it's saying, is it plausible? You always say, yes, it is plausible because anything could happen. But for part G, this is where you want to use the confidence interval because it's saying based on your confidence interval, is it likely that the true proportion of registered voters who are in favor of the death penalty for those convicted of murder is 75%. And in this case, we'll put no. Since 0.75 does not fall between 0.611 and 0.6486.
For part F, is it P or P hat?
P.
So for F is more of like, could this be the actual number? And it could be because, you know, that's just what it could be. Like is it saying, like if we flipped a coin 10 times and we got 50%, our confidence level, let's say 0.4 and 0.6, it could be 70% if we actually did it, right?
Yeah.
Like I'm a bit confused. Okay.
Yeah, pretty much like kind of think about it like anything could happen because we don't really truly know what could be the value of this P. Because for F, we're going based off of not knowing anything. Because for F, we don't want to use a confidence interval because it's not asking us to use the confidence interval. For part G, since it's asking us to make our decision based off of the confidence interval, that's why we're using the confidence interval that we found for part E for G. But for F, you just say like, hey, anything is plausible. It's plausible that it could be that like 5% of people are in favor of that, or it could be 60% of people are in favor of that, or 62. So anything is plausible. But for G, since they're asking us to use the information that we found from part E, so that's why you want to say no, since 0.75 doesn't fall in between 0.611 and 0.6486. All right. Any other question in regards to this one? Cool. All right. So let's do some more practice.
So can you scroll up a little bit? I just want to finish the last one.
Yeah. So for this example, it says Instructor Vallejo is interested in what % of baby sea turtle hatchling will survive to adulthood. He followed 1,325 baby seal turtle and only 14 made it to adulthood. Construct a 80% confidence interval for the % of baby sea turtle hatchling will survive to will survive to adulthood. All right, so let's do this one. So for this one, first thing we're gonna go ahead and do, let's go ahead and find what p hat is equal to. So if you look at p hat, what they're interested in is how many baby sea turtle will pretty much make it to adulthood. So if you look at it, they tell us only 14 baby sea turtle made it to adulthood. And you divide that by the total amount of baby sea turtle they were following. So we put 14 divided by 1,325. Everybody go for p hat. All right, so I'm gonna go ahead and calculate what p hat is equal to. So for p hat, we'll do 14 divided by 1,325. So you roughly get 0.010. And if you look at it, it says 5.6. So I'm gonna use the 6 to round up that 5 into a 6. So we'll say 0.0106. Right, so that's your answer for p hat. Any question for p hat? All right. So up and we're gonna go ahead and do, we're gonna go ahead and find z alpha divided by 2. So z alpha divided by 2. So remember, the only thing that I need for z alpha divided by 2, I just need to know the confidence level. So in this case, they tell us confidence level is 80%. So I had to go to the t-table and look up 80% confidence level. Any questions so far where the 80% come from? All right. So let me just switch over to my t-table. Right. So if you look at this one, we want to use 80%. So 80% is right over there. So we use 80%. If you look right above it, you get 1.282. So 1.282. So you get 1.282. So next up, what we're gonna go ahead and do, we're gonna go ahead and find margin of error. So for margin of error, we're gonna get 1.282. We're gonna multiply this by p hat, where p hat is 0.0106. Multiply by 1 minus 0.0106. All divided by my n, where n is 1,325. So I'm gonna go ahead and just do that on Class Calc, and that will give me my margin of error. So we'll say 1.282 multiply by radical 0.0106, and we're gonna do 1 minus 0.0106, close parenthesis, divide this by 1,325. Press enter. Get 0.00, I would say 36. So that's our margin of error. So we don't really have that much of a margin of error, but that's our margin of error. Any question in regard so far to our margin of error? All right. So we're gonna go over and transition back to the notes, and we're gonna go ahead and finish up this problem. So for the final step, you're gonna get p hat. and you're gonna add and subtract it to your margin of error. So we get 0.0106 plus and minus 0.0036. So let me go ahead and do that on my calculator. So we're gonna say 0.0106 minus 0.0036. We get 0.007. Then we'll say we add it, and we get 0.0142. All right. And that'll be it for that confidence interval. So the confidence interval for baby sea turtle hatching and surviving until adulthood. So we're saying with 80% confidence, that percentage should be somewhere in between 0.007 all the way to 0.0142. So it should be hopefully somewhere in between here. But just know this confidence interval, it could be wrong because it's either going to be inside of it or it could be outside of it. But we have an 80% confidence level on this one because that's what our confidence level. All right, and that's it for that last problem. Any question in regard to that last problem? All right, so I'm gonna show you how to double check the answer. So we go to the TI-84. So to double check your answer, you could go to the stats button. You could go over here where it says tests. And then if you just scroll down, you want to find the one that says one prop Z int. So you want this one. So we want one prop, just mean proportion, Z interval. Well, the INT stands for interval. So I'm going to select the one prop Z interval. For N, for X, if you look for X, X will be 14. And N should be 1,325. And lastly, your confidence level should be 0.80. So if you go to calculate, so if you look at it, we got approximately the same answer. The only thing a little bit different, we kind of rounded up because if you look at 0.00697, we just got the 9 and rounded up that 6 to 0.007. And if you look at the upper boundary, we got 0.01417, but we put 0.0142 because we use that as 7 to round up that 1 into 2. So you can always just use this to double check your answer just to make sure that you're doing correct. All right, but any question in regard to the last problem? All right, so let's go ahead and go to page 6 and let's do this next one. All right, so for this one, it says a assembly line does a quality check by sampling 50 of its product. It finds that 16% of the parts are defective. So for this one, you kind of want to just read the problem and just pretty much figure out what's given to us. So if you look at the 50 is our N value. So we know N is equal to 50. Because that's how many product they have. So we know they have a total of 50 product. So if you look at the 16%, the 16% is telling us the parts that are defective. So we know that they have 50 product, and we know that of those 50 products, 16% of them are defective. So that's our P hat. Everybody good for N is equal to 50, P hat is equal to 0.16.
So for this one, they gave us the P hat opposed to us having to divide like 8 by 50.
Correct. Yeah, for this one, they already gave us the information, so there's no need to divide. All right, so let's go to part A. So if you look at part A, it said create a 95% confidence interval for the percent of the affected parts of the company and interpret this interval. So for this one, you kind of want to read it correctly. So it's asking for two things. It's asking A, to create a confidence interval. But once you create the confidence interval, we also want to interpret what that confidence interval is. So we're gonna go ahead and we're gonna go ahead and find the confidence interval, and then once we're done with finding the confidence interval, we're gonna interpret it. All right. So we already know what p hat is equal to. We know it's 0.16, but we don't know what z alpha divided by 2 is. And just remember, for this one, you want to use the confidence level. So the confidence level is 95%. So we have to find z value when we have a 95% confidence level. So for this one, all we're gonna go ahead and do, we're gonna go back to this t table. And if you look right here, you're gonna get this value. Because if you look at it, it says 95% for confidence level. So right above it says 1.96. So we're gonna use 1.96 is our z value. $1.96 is our z value. So 1.96. Everybody get where the 1.96 come from? All right, lastly, we get margin of error. Margin of error is z, 1.96, multiplied by p hat, which is 0.16, times 1 minus 0.16, all divided by n. N in this case scenario was 50. Everybody good so far on how I inputted for margin of error? Okay, so up next we're gonna go ahead and I'm gonna transition over to the calculator, for that way I could just enter that information in. So we have 1.96, then you multiply that by a radical 0.16 times 1 minus 0.16, close parenthesis, you divide this by 50. All right, so if you look at this one, you get 0.1016. So if you look at the margin of error, you got a pretty big margin of error, because the margin of error it's giving us a margin of error of 10%. So telling us that we could be off by 10% of our point of estimate. So that's a pretty generous margin of error. So what we're gonna go ahead and do, go back to the lecture notes. All right, so if you look at the lecture notes, I got my E, which is 0.1016. So now what I'm gonna go ahead and do, I'm gonna go ahead and do my point of estimate. I'm gonna add it, I'm gonna subtract it to my margin of error. So we're gonna say, here, we'll do this. Let's do this in this thing. So we'll say 0.16 plus or minus 0.1016. So I'm gonna do that in my calculator. So you go 0.16 minus 0.1016. So you get 0.0584. And then you add it, which is 0.2616. All right, and that's how you find the confidence interval for this one. Any question in regard to how I found the confidence interval? All right, so if you kind of look at this confidence interval, telling us it could our true point of proportion could be anywhere between roughly 6% all the way to 26%. So it's kind of giving us a good option or a good range of option to choose from. So it's telling us the lowest it could possibly be is 5.8%. The highest it could be is 26%. All right. So for this one, I'm going to show you how to do it with the calculator. So
For our final answer, it should always be the two numbers, not the 0.16 plus or minus 0.1016.
yeah, correct. It should always be this value underneath.
Got it.
All right, so I'm going to show you how to do this with the TI-83. For that, we could double check your answer. Also, if you look at it, you don't have an X value. So before we actually go to the TI-83, what you want to go ahead and do, you want to go ahead and find the X value. Because if you remember the input for the TI-83 for the one prop Z interval, it asks you for three things. It asks you for the X, the N, and the confidence level. So right now we don't have the X value, so we kind of want to spend a moment to find that. So in order to find the X value, well, if you look at the formula, P hat is equal to X divided by N. So purely mathematically, if you go, we want to solve for X, so we want X to be by itself. So you want to multiply this by N, multiply this by N. So you get X is equal to N times P hat. So if you do N, which is 50, times P hat, which is 0.16, you get 8. So that's how you want to go about and finding the X value if ever you're not given an X value. And also just remember for the X value, it should always be a whole number. If you try giving the TI-83 a number that's not a whole number, it will give you a syntax error. So always give it a number that's a whole number. So to figure out what the whole number should be, just use the regular rule of thumb. If the value next to it is greater than or equal to 5, you round it up. If the value less than 5, then just round it down. All right. So let's go ahead and switch over to the TI-84. All right, so let's press on. So we go to stats, we'll go to tests, we'll go all the way down to one prop Z interval. And to kind of demonstrate how it will give you the wrong answer if you put a decimal. Oh, you do that. So we'll put 50. We'll put confidence level, which is 0.95.
How did you go to that again?
So to go to that, you go to stats and you go over where it says tests and you go all the way down where it says one prop Z interval. All right, so if you look at it, it gave me an error. It told me there's a domain error. So the reason why it's giving me there's a domain error because I put X is equal to a decimal and it doesn't really like that I gave X as a decimal because the thing is the X value should always be a whole number. It should never be a decimal value. All right, so let me change that to 8. That way it won't give me a syntax error. And if you look at it, it'll give me that value. So it gave me 0.05838, which we has got 0.0584. And then for the upper bound, it gave me 0.26162, which we just rounded it off to 0.2616. So it gave us exactly the same answer that we got by hand. Any question in regard to how to use the one prop Z interval? All right then. So up next, we're gonna go ahead and we're gonna do the interpretation. So for the interpretation should always have 3 things. So I'm going to go ahead and show you what are the 3 things that the interpretation should always have. All right, so the interpretation should always have how confident you are. So the confident, it should also have what is the population proportion in the context of the problem. And lastly, it should also have what is the confidence interval that you found. So for an interpretation of the confidence interval, it should always have how confident are you? It should have what is the population proportion in the context of the problem. And lastly, it should have what is the confidence interval. So let's go ahead and do that interpretation. All right, so the first thing we're gonna go ahead and do, we're gonna put the confidence level. So we're gonna say, let's do this. So say, we are, and then you put your confidence level. So for this one, we had a 95% confidence level. All right. So that checks off our confidence level. So we're saying we are 95% confident. So the next thing what you want to do, you want to put the population proportion in the context of the problem. So what are we trying to find? We're trying to find the proportion of defective product. Let's see. Yeah, so we're trying to find the proportion of defective product in this batch. So we'll say we are 95% confident that the population proportion of defective So that's the second thing. What you want is describe the population proportion in the context of the problem. So for this one, we're talking about defective products. So you just want to put that the population proportion of defective products is, and then you put whatever the confidence interval is. So in our case, the confidence interval is between, oops, too many W's, is between and if you want, you could put it as a percent or as a decimal. All you put as a percent, we'll say 5.84% and 26.16%. So we'll say we are 95% confident that the population proportion of the effective product is between 5.84% and 26.16%. And that's it for A. Any question in regard to A? All right, so up next we're gonna go ahead and we're gonna do part B. In part B, we're not gonna do any calculation. All we're gonna do is say what's gonna happen to the critical value the margin of error, and the confidence interval if we go from a 95% confidence level and if we decrease it to a 90% confidence level. So we just want to say what is going to happen to that value. Is the value going to go up? Is the value going to go down? Stuff like that. So right now what we're doing, we're getting a 95% confidence level. And we're saying we're going to decrease it to a 90% confidence level. So if I go from a 95% confidence level to a 90% confidence level, what's going to happen with the critical value? Should it go up or would it go down? And if you kind of remember the simulation that we did yesterday, well, not yesterday, sorry. Yesterday was Sunday. If you remember the simulation that we did on Wednesday, that should kind of help you out. Yeah. All right. So if the confidence level go from a 95% confidence level to a 90% confidence level, the critical value should be going down. Because if you're less confident, that could affect your critical value. Whenever the confidence level is decreasing, the critical value is actually getting smaller. If it would have been vice versa, if we would have gone from 90% to a 95%, your critical value then is actually going to go up. So let's go ahead over to margin of error.
Wait, which one is the critical value? Which calculation is the critical value?
The critical value is this one, V alpha divided by 2.
The alpha, okay.
Right. So let's go over to margin of error. So if you don't remember what margin of error is this one, V alpha divided by 2 multiplied by P hat, 1 minus P hat. All right, so say if, same thing, so if we go from a confidence level of 95% to a confidence level of 90%, what will happen to the margin of error? Will the margin of error go up or will the margin of error go down? All right. Well, if you kind of think about it logically, if your critical value went down, that means you're going to be multiplying by a smaller number. If you're multiplying by a smaller number now, it should be going down. So your margin of error will go down. All right. And lastly, your confidence interval. So for this one, actually we'll put wider, narrow. All right, so same thing. If we go from a confidence level of 95%, and if we go to a confidence level of 90%, for this one, your confidence interval should actually start getting narrower. Because kind of thinking about it, if you have a smaller range that's narrower, you're gonna be less confident in it because you're always more confident on a confidence interval that have a wider range. So for this one, for that part, it should be if our confidence level go from 95% and decreases to a 90%, we should be expecting a narrower range. All right, and that's it for that one. Any question in regard to part 3?